Welcome back to SK Educates. In today's video, I'm going to be teaching you a form of irrational numbers, also known as surds. As you can see, in the center of the screen, I have a list of the square numbers for 1 to 10, which is 1 to 100 inclusive. I really do recommend that you're comfortable with your square numbers in general. It makes the whole process a lot quicker and a lot easier. So let's just jump into the first part of this video, which is simplifying surds. Now, our first example here is root 8. Now, all you have to do is find the largest factor of 8 that is also a square number. So the largest factor of 8 that is also a square number would be 4. And 4 times 2 gives you 8, so you rewrite this as root 4 times 2. So all you've done is replace the 8 with 4 times 2. You can then split this and write it as root 4 root 2. It means the same thing. But we know that root 4 gives us an integer, a whole number. So we're going to rewrite this as 2 root 2 because root 4 is 2. And that's your final answer. Let's go to the next example. Here we have root 50. So the largest factor of 50 that is also a square number would be 25. And 25 times 2 gives you 50. So you rewrite this as root 25 times 2. You then split it by writing it as root 25 root 2. And we know, like before, that root 25 will give you a whole number, which will be 5, because square root 25 is 5. So your final answer is 5 root 2. Let's do another example. Here we have root 12. So the largest factor of 12, that is also a square number, would be 4. And 4 times 3 gives you 12. So we rewrite this as root 4 times 3. Hopefully you're getting the gist at this point. Equals, you split it to root 4 root 3. But we know that root 4 is 2, so we replace this with a 2. And it's going to be 2 root 3. Now I have 2 more examples of this. I do recommend pausing the video, trying it yourself, and then comparing your answer to mine. So here we've got root 300. So the largest factor of 300, that is also a square number, is 100. And 100 times 3 gives you 300. So I'm going to write 100 times 3. And you rewrite this as root 100, root 3. But we know that root 100 is just 10. So the final answer would be 10 root 3. Again, pause the video for the next one. Try it yourself. So the largest factor of 45, that is also a square number, is 9. And 9 times 5 gives you 45. So I'm going to rewrite this as 9 multiplied by 5. You split it and write it as root 9, root 5. But we know that root 9 is just 3, so the final answer is 3 root 5. And this is the first part of surds. Now, just before I move to the next section, I'm just going to show you what would happen if you weren't to use the largest factor that is also a square number. What I mean by that is, let's take this example with the root 300. Let's say for some reason you didn't realize that 100 was the largest factor that's also a square number, and you thought it was 25. So you rewrote this as root 25 times 12. Well, if we continue to simplify this, what you'll get is, you split it first, so you have root 25, root 12. But we know that root 25 will give us an integer, so we write it as 5 root 12. Is this fully simplified yet? No. Because we didn't use the largest factor that was a square number, it means that we have to simplify again with the root 12. And if you remember, we did it before. We know it's 2 root 3. But it just adds extra steps. So try and work out what the largest factor is that is also a square number, or the process will become a little bit longer. Not harder, just a little bit longer. So you'd have to replace this with 2 root 3. This will give you 10 root 3. So cool, let's go to the next section, which is simplifying surds part 2. So there's 2 ways to approach this. The first way is to simplify these both separately and then combine them. Or you could simplify the surd by making it root 20 times 5, which is root 100, and then simplifying it from there. I'm going to show you both ways. With this one, I'm going to deal with each of them separately. So, with the root 20, what is the largest factor of 20 that is also a square number? It's 4. So I'm going to rewrite root 20 as root 4 times 5, because 4 times 5 gives you 20. And then we have times root 5 here. Root 5 can't be simplified because 5 is a prime number. So now we split this and write as root 4, root 5, multiplied by root 5. And then we know that root 4 is just 2. So I'm going to write this as 2 root 5 times 5. Okay, now we can go on to learning something new that's really important. When you multiply a surd together by the same surd, so if I have root 5 times root 5, you just end up with 5. This would work with any number. Let's say you had root 102 times root 102. It could literally be any number. The answer would be 102. So, now if we have 2 root 5 times root 5, well, we know that root 5 times root 5 just gives you 5. So we essentially just have 2 times 5. So your final answer is 10. So that was one way to do it. I'm going to show you the other way to do it with the second example. So here we have root 200 times root 2. This is equal to root 400. And this is a perfect square, so we can just simplify this to 20. But otherwise, you just do what we did before. Find the largest factor that's a square number and simplify like so. So just to run over that, the first way is to deal with them separately like I did here and then combine at the end. Or you could just multiply these by each other and then simplify this larger surd, whatever you're comfortable with. Let's go to the last example. So I'm going to combine these together. So this is root 5 times root 10 times root 2. So all I want to do is put it under one root and just multiply all the insides together. So 5 times 10 gives you 50, times by 2 gives you 100. And again, by coincidence, this is a perfect square because root 100 is just 10. And again, that's your final answer. Now let's move on to something called rationalizing the denominator. The one thing we do not like is having irrational numbers as our denominators. We can have them on the top, so we can have them as numerators, but the denominator, we would want an integer. So think about what we just learned in the previous section to change this root 2 into a rational number. If you don't remember, I told you before that if you multiply a surd by itself, you're just left with the number inside the root. Therefore, I'm going to times the denominator by root 2. But whatever you do to the bottom, you have to do to the top. And then our denominator becomes 2, which is what we want because now it's not irrational. Root 50 times root 2 gives you root 100. But we know that root 100 is just 10, so we have 10 over 2. And 10 divided by 2 is 5. And that's your final answer. So our next example is 4 over root 3. Again, we don't want the root 3 there. So what I do is multiply it by root 3 at the bottom. But whatever you do to the bottom, you have to do to the top. So we're left with, on the denominator, root 3 times root 3 gives us 3. And then 4 times root 3 is 4 root 3. And you cannot simplify this anymore. That's your final answer. Let's go to the next one. So here we have root 30 times root 12 over root 2 times root 5. I would combine them at this point. So root 30 times root 12 gives you root 360. And then root 2 times root 5 gives you root 10. But again, the denominator is still irrational, so how do I get rid of it? Just multiply it by itself. But whatever you do to the bottom, you have to do to the top. So I'm timesing the top and bottom by root 10. And I'm going to be left with root 3,600 over root 10 times root 10 just gives you 10, which is what we want. Root 3,600 just gives you 60, so we have 60 over 10. And 60 divided by 10 is 6. And that's your final answer. Now our final example. Here we've got 6 over 3 root 10. Again, this root 10 is causing problems because it makes our denominator irrational. So to get rid of it, or to change it, should I say, we multiply the top and bottom by root 10. So times the bottom by root 10 times the top by root 10. And what are we left with? On the denominator, we have 3, and then root 10 times root 10 just gives you 10. So you have 3 times 10. And on the numerator, we just have 6 root 10. So simplifying this further, you have 6 root 10 over 3 times 10 gives you 30. Now, just as a note, root 10 doesn't have a factor that is a square number, so you can't simplify that anymore. But we can divide the top and bottom by 6. So if I divide the top by 6, that becomes a 1. If I divide the bottom by 6, that will become a 5. So our final answer is 1 root 10, which is the same as root 10, over 5. And that's your final answer. Now let's move on to expanding and simplifying. So this is essentially the same as normal expansion. We just have surds now. So let's take the first example. Like always, you multiply the outside term by each of the terms on the inside. So let's do that. Root 3 times 5 just gives you 5 root 3. And then root 3, sorry, there's a car going by. And then root 3 times root 3 just gives you plus 3. And that's your final answer. You simplified it. Remember, because when you multiply a surd by itself, you just get the number inside the root. Let's go to the next one. This is a double bracket. Like before, you take the first term in the first bracket and multiply it by each of these. So 5 times 6 is 30. 5 times root 3 is 5 root 3, so plus 5 root 3. And then we're going to do this with the other term, which is a root 3, multiply it by 6. So root 3 times 6 gives you plus 6 root 3. And root 3 times root 3 is the same surd, so you just get the number inside the root, so it's just plus 3. So now we can simplify. All you have to do is collect the 30 and the 3. So 30 plus 3 gives you 33. And then 5 root 3 plus 6 root 3, you just add the coefficients together. So 5 plus 6 is 11, so we have plus 11 root 3. And that's your final answer. Let's go to our final example. I do recommend pausing it at this point, trying it yourself. So here we have 2 plus root 3, 4 plus root 2. So again, I'm going to do 2 multiplied by 4, which is 8. And then 2 multiplied by root 2, which gives you plus 2 root 2. Then we have root 3 times by 4, which is plus 4 root 3. And then we have root 3 multiplied by root 2, which will give you plus root 6. Because remember, when you multiply them, you just do 3 times 2 and then put it in the root. And you now actually can't simplify any of these terms. Before, we had 2 root 3's, right? So we just added the coefficients. But here, all of the surds are different. Therefore, we can't simplify them. And again, the 8 will be left on its own because there's no other whole number to add it with. So this would actually be your final answer. Let me just add another example here. Let's say we had 1 plus root 2 multiplied by 1 minus root 2. So let's simplify this like before. You take this term and multiply it by each of these. So 1 multiplied by 1 gives you 1. 1 multiplied by minus root 2 will give you minus 1 root 2, or just root 2. And then we do root 2 multiplied by 1, which is again plus 1 root 2. And then root 2 multiplied by minus root 2. Remember, when you multiply the same surds together, you just get the number on the inside, but there's a minus here, so we're just going to have minus 2. Now let's simplify. So 1 minus 2 gives you minus 1. And then minus 1 root 2 plus 1 root 2 just cancels out. So this is your final answer. Keeping this example I just did in mind, let's go on to the final section of this video, which is rationalizing part 2. How do I rationalize a denominator when the denominator is a summation where one of the terms is also a surd? Well, if we look at the denominator, what can we multiply it by to make it rational? Well, before, when we multiplied 1 plus root 2 by 1 minus root 2, the surds ended up cancelling and we were left with a rational number. So here, whatever you do to the bottom, you do to the top though. So I'm going to multiply this. I'm going to put brackets around it to make it clearer. I'm going to times the bottom by 1 minus root 2 and the top by 1 minus root 2. So with the denominator, I'm going to use the expansion from before. It just simplified to minus 1, right? So the denominator just becomes minus 1. And our numerator, 1 multiplied by 1 gives you 1. And then 1 multiplied by minus root 2 gives you minus root 2. So this is your final answer. And you can always simplify this and write it as root 2 minus 1. I just divided each of the terms separately by minus 1. Go on to our next example. So here we have 2 minus root 5. So what do we have to do to make this denominator rational? Well, you multiply it by 2 plus root 5. Whatever I do to the bottom, I have to do to the top. So I have to multiply this by 2 plus root 5. So let's deal with the denominator first. So we first expand this. That line isn't very straight. We first have to expand this. I want to do 2 multiplied by 2, which gives me 4. Then we do 2 multiplied by plus root 5, which is plus 2 root 5. And then we're going to do minus root 5 multiplied by 2. That just gives you minus 2 root 5. And then minus root 5 multiplied by plus root 5. Remember, when you multiply the same side together, just get the number on the inside. And we have a minus sign here, so it's just going to be minus 5. And on the numerator, we do 8 times 2, 16. And then 8 times root 5, which is plus 8 root 5. Now let's simplify. So on the top, we have 16 plus 8 root 5. And on the denominator, 4 minus 5 just gives you minus 1. And then plus 2 root 5 minus 2 root 5 cancels. So this is your final answer. Which again, if you divide by minus 1, you just get minus everything. So it's minus 16 minus 8 root 5. And this is your final answer. Let's go on to the final example. Here I have 3 plus root 2 over 3 minus root 2. So I want to rationalize the denominator. So all I have to do is multiply it by 3 plus root 2. But whatever you do to the bottom, you must do to the top. So we multiply the top by 3 plus root 2 as well. Now, simplifying both of them, let's deal with the denominator first. Let me use a different colour. So, 3 multiplied by 3, 9. 3 multiplied by root 2 is plus 3 root 2. Then we do minus root 2 multiplied by 3 gives you minus 3 root 2. As you can see, they're already going to cancel. And then minus root 2 multiplied by plus root 2 will just give you minus 2. Now for the numerator, 3 multiplied by 3 is 9. 3 multiplied by root 2 gives you plus 3 root 2. Then root 2 multiplied by 3 gives you another plus 3 root 2. And then root 2 multiplied by root 2 gives you 2. Now let's simplify the top and bottom. Let's go with the bottom first. So 9 minus 2 gives you 7. And the plus root 3 and the minus root 3 cancel out. Now for the top, 9 plus 2 gives you 11. And then plus 3 root 2 plus 3 root 2 gives you plus 6 root 2. And this, again, is your final answer. Now that's the end of all the topics that I'm covering in this video. In the description box below, I'll leave a link for different resources you can use to do extra practice. It's so important to practice or you'll forget what we learned. But yeah, have an amazing day and I'll see you in my next video. Don't forget to like, comment and subscribe, and leave a comment down below on what topics you'd like to see sooner.